Hello friends, I welcome you to my YouTube channel Make PM. So in today's video we will solve another problem of a fraction research of linear programming based on the graphical method. And in previous videos we have seen that we had already been given mathematical models, like we had been already given the various objective functions and various constraints, and we have to just solve them. But in this problem the various statements are given and we have to formulate the problem and then solve it. So let's see how to formulate the problem of linear program. So let's read out the problem. Anita Electric Company produces two products, P1 and P2. So let's note down the details. P1 and P2 are two products and sold on the weekly basis. The weekly production cannot exceed 25 units for product P1 and 35 units for product P2. So P1 is less than or equal to 25, P2 is less than or equal to 35. Because of the limited facility, the company employs total of 60 workers. So workers have restrictions which is equal to less than or equal to 60. Products P1 require 2 man week of labor, while P2 requires 1 man week of labor. So 60 hours is available for both the products. So adding the total time of both the products should be less than or equal to 60. So 2P1 is time number of workers required for product P1 plus P2 is less than or equal to 60. How? Because P1 requires twice the time of the labors than P2, and total value of the total workers will be equal to 60, which is given in the problem. Profit margin of P1 is 60 and P2 is 40. So our objective function, formulate this problem and solve the graphical method. So our objective function z is equal to profit. So what is profit? 60 P1 plus 40 P2. This is our profit. So our objective function is this, and we have to maximize this profit because no company wants to minimize their profit. So we will maximize this profit. Now we have written down various conditions, and we will assume that P1 and P2 number of products would be always greater than 0. So our objective function is 60 P1 plus 40 P2, and our constraints are P1 is less than or equal to 25, P2 is less than or equal to 35, and 2P1 plus P2 is less than or equal to 60. Okay, so we will convert this in equality. Our conditions will become P1 is equal to 25, P2 is equal to 35, and 2P1 plus P2 is equal to 60. Here if P1 is 0, then P2 will become 60. So this will be 0 and 60, and if P2 is 0, then P1 will become 60 by 2, which is 30. So 30 and 0 will be point on the y-axis, sorry, x-axis. So let's draw the graph. Let's divide divisions of 10, 10, 20, 30, 40, 50. This is P1 axis, this is P2 axis. So line first constraint 2p1 plus p2 is less than or equal to 60 is passing through 0 60, which is here 0 60, and 30 0, which is here. So this is our first constraint, and second one is p1 is equal to 25. So p1 is 25 is this, and second one is p2 is equal to 35. Now what are the conditions? X1 is equal to p1 is equal to 0 is this line, and p2 is equal to 0 is this line. So what are the constraints? We will see that 2p1 plus p2 is less than or equal to 60. Less than or equal to 60 means downward side, this area. p1 is less than or equal to 25, so left side. p2 is less than or equal to 35 means downward side, and x1 is equal to 0 greater than 0, f2 is equal to greater than 0 means in first quadrant. So we can say that this area is common. So this is feasible region, means in this region we will find the feasible solution, but we have to maximize the profit, so we have to look for the extreme points. So extreme points are, suppose this is A, this is B, this is C, this is D, this is E. Okay, so we have to calculate the coordinates of the point B and C. So what are the coordinates of point B? So at point B, the line 2p1 plus p2 is equal to 60, and the line p1 is equal to 25 are intersecting. So we will solve these two, then we will find this point B. So it will be, if we put p1 is equal to 25 in this equation, then we will get 2 into 25 plus p2 is equal to 60. 50 plus p2 is equal to 60. So p2 will be 10. So p1 is 25 and p2 is 10. So this point is 25, 10. Similarly, at point C, we can say that this line 2p1 plus p2 is equal to 60, and p2 is equal to 35 or intersecting. So if we put value of p2 in this equation, then we get 2p1 plus 35 is equal to 60. From here we will get 2p1 is equal to 60 minus 35, which is equal to 25. So p1 is 25 by 2, which is equal to 12.5. So our point is 12.5 and 35. So this point C is 12.5 and 35. Now we will try to maximize our profit. So we will write the points, extreme points, then we write coordinates, then value of objective function, which is z is equal to 60p1 plus 40p2. From here you can see the coordinates are here. Points is A, B, EAB, and C and A. C and D. What are the coordinates? Point A is 0, 0. Point A is 25, 0. Point A is 25, 0. Point B is 25, 10. Point B is 12.5, 35. Sorry, point C is 12.5, 35. Point D is, here it is, 35, 0, 35. Now we will find the value of Z here. Z is equal to 60 into 0 plus 40 into 0, which is equal to 0. At point A is 60 into 25 plus 40 into 0, which will be equal to 1500. Now at point B it is 60 into 25 plus 40 into 10, which will be equal to 1500 plus 400, which will be equal to 1900. At this point C, it is 60 into 12.5 plus 40 into 35, which will be equal to 2150. And this point it will be 60 into 0 plus 40 into 35, which will be equal to 1400. So you can see that maximum value of Z is 2150. So we can see that maximum value of optimal solution is Z is equal to 2150. And at this point the value of the products are 12.5 and 35. It means that if you produce the 12.5 units of this product P1 and 35 unit of product P2, then we will have the maximum profit of Z, which is equal to 2150. So I hope you understood how to formulate these problems and how to solve this by graphical method. If you have any doubt, then please ask in the comment section, and if you like the video, then please subscribe to our channel. Thanks for watching.